To add a little bit more detail to this idea of coming out of the Younger Dryas, along the way, this long-term cooling that we have seen probably interacted with the evolution of these various species of humans and their migration, and the extinction of several of the megafaunas. So the idea is always try to separate the human impact versus climate impact on megafaunal extinction, and how humans changed their diet from big game hunting and meat eating high protein diet to domesticating wild crops, cereals, grains, and becoming shifts in diets, and how that could have affected health and evolution as well. So here is a map of Natufian sites in Eastern Mediterranean. This is the hotspot where we all the evidence says that agriculture evolved, and human beings discovered that there were grasses, wheats, rice, other things that could be domesticated and consumed. And the climate change occurred differently, so probably South America, Eurasia, Australia, and so on, various places probably simultaneously evolved various forms of agriculture along the way, rice becoming dominant in one place, wheat becoming dominant in another place, and so on and so forth. So all those details matter in terms of how different health vulnerabilities, genetics would have evolved. But in general, if we look at the megafaunal extinction along the way, if we go to 50 to 20 kilo years and look at megafaunal extinction in terms of species numbers 9, 8, 33, 50, and 21, and causes of extinction, whether it's humans, climate, or there is not enough data to say for sure, and the confidence limits associated. So provisional evidence, robust evidence versus needing more work, and so on. Looks complicated, but the main message I would leave with is that there is the least bit of extinction evident in Africa, even though we know humans lived there for the longest, like 160,000 years at least, and yet the data doesn't point to climate or human influence, but maybe there is not enough evidence, and the number of extinctions are highest in South America, Australia, North America, and so on. So the idea is that co-evolution of humans and many of the species over here probably allowed coexistence, and when humans migrated to newer places, they either hunted them down as threats or for food. Okay, so the woolly mammoth, for example, went extinct only few thousand years ago in North America, and whether that was related to climate or not. So there is robust evidence here over this period where the transition happened out of the last ice age. Okay, so you can see that these kind of things take a lot of work, and you have to be able to attribute with confidence about of the cause to humans or climate. But nonetheless, the evolution of agriculture and the extinction of megafauna would have forced humans to change also not only the diets but sources of other proteins like milk and eggs into sheep and cattle and chicken and so on. And there is some evidence that shift to agriculture and grains negatively affected humans in terms of their height, their health, some of the health issues, and so on. So there is an impact on health as well as morphology. And we are transitioning now into, so we became agriculturalists, we became settled communities as opposed to hunter-gatherers who were mostly moving around a lot. This led to increases in fertility rates, family structures, growth of settlements, even cities, more number of infectious diseases, and also just exposure to more pathogens by staying in one place, and many other health impacts. And population growth started along the way, deforestation and habitat changes started along the way. Then we became better and better at agriculture, and industrial revolution came along. So if we look at the changes since about the 16th century to the present, looking at decreasing species along according to the International Union of Conservation Network, classified endangered or low concern here. So this greenish color is low concern, and endangered is this brownish color here. So we are looking at land vertebrates, lots of them, almost 65 to 70% endangered. Mammals, even more, 75%. Birds, this is increasing more and more now. Reptiles, quite endangered, and amphibians have been kind of an indicator species for impacts of humans, including acid rain and so on and so forth. So this is the argument for the so-called sixth extinction, a book by Elizabeth Colbert that you can look up, and it is very clear that now it's not so much in debate that climate, especially natural variability, is doing this thing. It is about direct human impact in terms of habitat changes or pollution and acid rain, or urbanization and destruction of habitats, or impact through climate change, and impact through predator-prey relations, like removing the predators of certain species, maybe increase in disease pressure, for example, warming, pathogen increase in the ocean, warming, virus load increase, disease pressure on fisheries, in addition to fishing pressure, and so on and so forth. So it's a complicated mess in terms of how many ways humans affect other species, but it's argued pretty strongly now that we are in the sixth extinction. But the main story we want to focus here, of course, is how human ecology is changing, either through natural climate variability and species changes, or our own impact on our ecology, and how that affects everything, including our health. So in the next chapter, we'll build more towards specifically how health impacts arise out of human ecology. So this is like a brief run through the evolution of humans and other events like mass extinction, biodiversity changes, vegetation changes, pathogen changes, diet changes, human species changes themselves, and so on. Okay, you can read up more details. I'm keeping it short basically because I want to use this book to give the big picture, and then get into other philosophy of doing climate and health, where we get more specifically into public health in a slightly different philosophy, as opposed to community health, which is kind of what Tony Michael argues for. Okay.